So, you want to build Android from scratch? Before you even type repo sync, you need to understand that you're about to undertake one of the most demanding software compilations on the planet. Notice the highlighted text. It's not an exaggeration. This process can bring even high-end workstations to their knees if they aren't configured perfectly. This isn't like compiling a simple app, it's compiling an entire operating system, and the rules are different. So let's build your professional environment the Google way. Every developer asks if they can build on a Mac or Windows. The short answer is no, not for serious work. Here's what actually happens under the hood. The build system, as you see highlighted, is deeply optimized for the Linux kernel's process and file system APIs. Using wrappers like WSL2 introduces I/O and process forking overhead that can cause bizarre, hard-to-debug build failures and will always be slower. At Google, we treat Linux as the only supported platform for a reason: reliability and performance. Now, which Linux? The official answer is always Ubuntu LTS. This isn't just a preference, it's a hard dependency. As the highlighted line shows, for modern Android versions, you absolutely need a specific LTS release. The build tools link against very specific versions of system libraries and compilers provided by these releases. Using a different distro or a non-LTS version means you're on your own, debugging library incompatibilities instead of working on Android. Most people trip over this when they try to build an older Android version like Oreo on a modern Ubuntu install. It will fail, guaranteed. That's because, as you can see here, older Android branches have a strict dependency on older toolchains like GCC 4.8, which are deprecated and unavailable on modern systems. This is why platform engineers often maintain multiple build machines or use containers to create these very specific older build environments. Before you do anything else, you need to confirm what you're working with. You can see the command highlighted on the screen. Running lsb_release-a gives you the ground truth of your Ubuntu environment. This is the first thing I ask a new engineer to run when they report a build issue. If the output of this command doesn't match the AOSP documentation for the branch they are building, we found the problem 90% of the time. Let's talk about hardware, and I need you to be realistic. Attempting a full AOSP build on a standard consumer laptop is a recipe for frustration. As the text here mentions, you'll either run out of memory and crash, or the build will take so long it becomes useless for iterative development. A professional AOSP engineer needs a dedicated, powerful machine. This is not a place to cut corners because time is your most valuable resource. The very first wall you will hit is disk space. I've seen it happen to dozens of new engineers. They follow all the instructions, kick off a build, and then it fails 6 hours later with no space left on device. As the highlighted text says, storage is the first and most common bottleneck. You need to plan for this before you even download the source code because the requirements are often shocking to newcomers. Let's break down why you need so much space. The first chunk, as you see highlighted, is the source code itself. Just checking out a single branch of AOSP, like main, will consume about a quarter of a terabyte. This is because it includes the entire history of every file, not just the latest version. This Git metadata is huge but essential for development, allowing you to switch branches and track changes efficiently. The source code is only half the story. The real consumer of space is the build output. Here's what actually happens under the hood. Every single component, from the kernel to the smallest app, gets compiled into an intermediate object file, then linked into a final binary or library. All of these artifacts, as noted here, live in the out directory and can easily consume another 150 to 200 gigabytes of space for a single device target. So let's do the math. As you can see highlighted, the absolute bare minimum you need is 400 gigabytes. And that's just for one build of one target. The trick that took me years to learn is to always over-provision. If you plan to use Ccache to speed up subsequent builds, which you absolutely should, you need to budget at least 500 GB. And frankly, a 1 terabyte drive is a much safer, professional starting point. Now, not all storage is created equal. If you try to build AOSP on a spinning hard drive, you will fail, or it will take days. The build system, Ninja, reads and writes millions of small files. The latency of a mechanical drive makes this impossible. As the text here states with emphasis, a fast NVMe SSD is mandatory. The difference is not minor. We are talking about a 10x or greater improvement in build times just from the storage medium. After storage, the next resource that will kill your build is RAM. Here's what's happening. The build system spawns dozens of parallel compiler processes to use all your CPU cores. Each of these processes consumes a significant amount of memory. If you run out, the Linux kernel's OOM killer, highlighted here, will unceremoniously terminate your build with no warning. It's not a crash, it's the OS protecting itself.
Can you get by with 16 gigabytes? Technically, yes, but it's painful. As the highlighted text explains, you will be heavily reliant on swap space, which means your system will be constantly writing memory pages to your slow disk. This is called thrashing, and it will make your build incredibly slow and the machine unresponsive. You're essentially trading a RAM bottleneck for a disk I/O bottleneck, which defeats the purpose of your fast SSD. So, what's the real number? For any serious work, 32 GB is the recommended starting point. But inside Google, the standard for a platform engineer's workstation is 64 GB of RAM or higher. This allows us to run a full parallel build, run an emulator, and have Android Studio open simultaneously without ever worrying about the OOM killer. This is the professional standard you should be aiming for. Just like with your OS version, you should verify your available memory. The command you see here, free-h, gives you a human-readable summary of your total, used and free RAM, as well as your swap space. Run this command in another terminal during a build, and you will see exactly why 16 GB isn't enough. You will see the available memory drop to near zero very quickly. Finally, let's talk about the engine of your build, the CPU. The relationship here is beautifully simple, as the highlighted line states. The more cores you have, the more parallel compilation jobs you can run, and the faster your build will be. It's an almost linear relationship. Doubling your core count will roughly halve your build time, assuming you have enough RAM and I/O to support it. To put this in perspective, look at the numbers highlighted here. A high-end desktop with a 16 or 32 core processor can complete a full build in under an hour. This is what allows for rapid, iterative development. In contrast, a typical 4-core laptop might take an entire workday. This is the single biggest hardware investment you can make to improve your productivity as an AOSP developer. With your hardware and OS ready, you need to organize your workspace. Don't just start downloading things to your home directory. The trick that will save you headaches later is to create a dedicated, isolated directory for all your AOSP work, as recommended here. This keeps the source code, the .repo directory, and the massive out directory all contained in one place on your fastest drive. The commands you see here are simple but important. Create a directory like AOSP-workspace in your home folder and immediately change into it. From this point forward, every repo command and every make command should be run from inside this directory. This simple discipline prevents stray files and makes it easy to manage multiple checkouts or completely clean your workspace if needed. Here is a critical warning that most people learn the hard way. Notice the highlighted text. Never, ever place your AOSP workspace inside a folder that is synced by Dropbox, Google Drive, or any other cloud service. Here's why. The AOSP checkout contains over 2 million files. The sync client will try to scan and upload every single one, consuming 100% of your CPU and network bandwidth, and it will likely crash before it ever finishes.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.